We have now used supermesh analysis when a current source blocks a direct KVL path. The next twist is a dependent current source. The method is the same, but one source value is not a fixed number. It depends on a circuit variable, so we must write one extra relation before solving. In this circuit, the target is VA. The left resistor is 4 kilo ohms, the right resistor is 12 kilo ohms, and the top voltage source is 24 volts with plus on the VA side. The left current source is 12 milliamps upward. The middle diamond source points downward and has value 2 times VA milliamps. We choose clockwise mesh currents I1, I2, and I3. Start with the two current source constraints. For the 12 milliamp source, the shared branch relation is I2 minus I1 equals 12 milliamps. For the dependent source, the relation is I2 minus I3 equals 2 VA milliamps. Now relate VA to the left mesh current. With the chosen polarity, VA equals negative 4 I1 volts, because 4 kilo ohms times I1 milliamps gives volts. Substituting this into the dependent source constraint gives I2 minus I3 equals negative 8 I1, or 8 I1 plus I2 minus I3 equals 0. The outer supermesh KVL equation skips the two current source branches and gives negative 4 I1 minus 12 I3 equals 24. Solving these three equations gives I1 equals negative 1.5 milliamps, I2 equals 10.5 milliamps, and I3 equals negative 1.5 milliamps. Finally, VA equals negative 4 times negative 1.5, so VA is 6 volts. A dependent source does not change the supermesh workflow. It only adds one bookkeeping step: express the dependent source value using the chosen mesh variables. Here, the key link was VA equals negative 4 I1. After that, the current source constraints and the outer KVL equation formed a normal three-equation system. The final answer is VA equals 6 volts.